This question is taken from a CAPE past paper, May, June 2014, number 1. Part A gives us a function f of x equal to 1 minus x squared defined on the set of real numbers. That means that this function spans the range of real numbers, or the real numbers, positive and negative. We are required to show that f is not a one-to-one function. We can do this in two ways. Now, a one-to-one function is a function such that every x in the domain goes to a different y in the range. In other words, we cannot have two different x's being mapped onto the same y. So to show that f is not one-to-one, we need to find two different x's that map to the same y. Now, when x is equal to 1, for instance, f of x will be equal to 1 minus 1 squared, which is 1 minus 1, which is 0. When x is equal to minus 1, f of x will again be equal to 0. So those are two different x values, 1 and minus 1, that map to the same y value. And for that reason, f of x is not a one-to-one function. Both 1 squared and minus 1 squared are equal to 1. So those two different x values map to the same y value. That cannot happen with a one-to-one function. So that was one way. Since two different x values map to the same y value, f is not one-to-one. Now, another way we could have done it is by graphing 1 minus x squared and carrying out the horizontal line test. 1 minus x squared, you should know from your quadratics, is going to be a maximum curve. So if I draw a rough sketch, it will have a maximum value of 1, and the two x-intercepts, we actually just found them, the x-intercepts occur where y is equal to 0, are 1 and minus 1. Minus 1 and 1. So this would be a rough sketch of y is equal to f of x. If we carry out a horizontal line test, here for instance, we see that two different x's map onto the same y, and therefore it's not one-to-one. Part 2, we have another function, g of x equal to a half x minus 3, again defined on the set of real numbers. So any composite function involving f or g, or both f and g, as is the case in part A here, will have a domain that's defined on the set of real numbers. We are required to find f of g of x and state its domain. Immediately we can say that the domain will be the set of real numbers. F of g of x means that we must map g into f. So f of g of x is f of half x minus 3. So anywhere in f that we see an x, we replace it with a half x minus 3. So 1 minus a half x minus 3 all squared, and that is equal to 1 minus, square this, that will be quarter x squared minus 3x plus 9. That is equal to 1 minus a quarter x squared plus 3x minus 9, which is equal to minus a quarter x squared plus 3x minus 8. That's f of g of x, and the domain will be, as I mentioned before, the set of real numbers. Determine g inverse and sketch the graphs of g and g inverse on the same pair of axes. So first step, we let y be equal to g of x, which is a half x minus 3. then we interchange x with y. When finding the inverse, what the inverse of a function does is that it maps back the y's onto the x's. So we're going in the inverse or the opposite direction. So for that reason, we interchange x and y. So wherever we see a y, we replace with x. Where we see an x, we replace with a y. And then we make y the subject of the formula, and that will be g inverse of x. Good. Therefore, y is equal to g inverse of x, which is equal to, so we multiply both sides by 2. This will be 2x plus 6. So that's g inverse. Sketch the graphs of g and g inverse on the same pair of axes. G inverse will be the reflection of g in the line y equals x. Now, if you notice, both of these graphs are linear. Both are of the form y equals mx plus c, both g and g inverse. If we plot g inverse, y equals 2x plus 6 has a y-intercept of 6, so 2, 4, 6. 2, 4, 6. Here we have 1 point on g inverse, and if we let x be equal to minus 1, then 2 times minus 1 is minus 2 plus 6 is 4. Y will be equal to 4 when x is minus 1. That will be another point on the graph of y equals g inverse x. To get the corresponding points on g of x, we reflect in the line y equals x. Now the line y equals x is the line that passes through 2, 2, 4, 4, 6, 6, etc. So whatever y is, x will be the same. We must also label that line. 0, 6 becomes 6, 0 when we reflect it. So that's the corresponding point on g. G inverse, this is g. And we had minus 1, 4. So we will need to have 4 minus 1. That will be there. Join them with a straight line. And we see that g and g inverse are mirror images of each other in the line y equals x. Part B, we have an expression, a cubic expression divided by 2x minus 1, and we're given the remainder as minus 3.5. We need to find the value of a. So the first thing we do is we give the function a name. Let f of x be equal to, so the expression is given a name by the remainder theorem. By our remainder theorem, f of, now 2x minus 1 is equal to 0 when x is a half. So f of a half will be minus 3.5. So we substitute that in and equate f of a half to minus 3.5. So anywhere we see x, we replace it with a half. And put it equal to minus 3.5. A half cubed is 1/8, by 2 is a quarter, plus a quarter a, minus 5 on 2, minus 2 is equal to minus 3.5. We're going to put everything over 4. 1 plus a minus 10 minus 8 is equal to minus 14 over 4. Denominators are the same, therefore numerators must be the same. So 1 plus a minus 10 minus 8 is minus 14. A is equal to minus 14. Minus 1 plus 10 plus 8, a is equal to 3. The length of a rectangular kitchen is y meters and the width is x meters. If the length is half the square of the width and its perimeter is 48 meters, we need to find the values of x and y. Good, so we know that the length is y, the width is x, and the length, y, is half of the square of the width, that's a half x squared. perimeter of a rectangle is 2 times the length plus 2 times the width, and that's equal to 48, and we know that y is a half x squared. So 2 times y plus 2 times x is 48. This will be x squared plus 2x. If I bring the 48 across, it becomes minus 48. This will factor as x plus 8 by x minus 6 equal to 0. Therefore, x is minus 8 or 6. X cannot be equal to minus 8 because we cannot have a negative length. And therefore, x must be equal to 6. When x is 6, y is, remember, is a half by x squared, which is a half of 36, which is 18 meters. So x will be 6 meters and y will be 18 meters. The length of the kitchen is y, so the length of the kitchen is 18 meters.